Later in Unit 4, we'll study the concept of algorithms and how that when a computation is performed, there's often trade-offs that we have to consider. If you think back to the last example we did with compression and run length encoding, the idea of compression is to reduce the size of a piece of data so that we can transfer it or store it in a much reduced space compared to the original. So when we're making trade-offs in terms of compression, there's a size versus fidelity issue. So we'd like to have smaller size, but we also want to make sure that we are not destroying the content of the data. Now, sometimes the data is destroyed in terms of having a more reduced size, and that in some cases that may be okay. So it all depends upon the situation. So there's various lossless compression algorithms, and the goal of lossless compression is to reduce the overall number of bits to represent data, while also allowing that original data to be perfectly reconstructed when it's needed. In the run length encoding example from the past is such a case. In the popular zip format, many students may have used zip before, where they try to take many files and put them into a single file that's compressed. So ask your students what would be the disadvantage if zip was not lossless. The idea of not being able to recover your original data would be pretty important in that particular case. There's also various graphics images that are graphics file formats, the graphic image format, the tagged image file format, and the portable network graphics formats are also examples of lossless compression. Likewise, there's the idea of lossy compression, where we also reduce the number of overall bits, but through the use of inexact approximations, it may be the case that there's some loss of information whenever you try to recover the original data. So the lossy compression may actually provide a stronger reduction in size of the file, but at the expense of being able to recover the original. So JPEG, MPEG, MP3 are very popular formats that your students may be familiar with in terms of photos and movies and songs that are examples of this. So being able to point out to your students this important trade-off could be useful in understanding not only the algorithms, but even in daily life how they make these kind of decisions when choosing certain ways to represent their data. So leading into an additional activity related to text compression, maybe you could ask your students to think of some commonly used text messaging acronyms. So many students have smartphones, and even those who don't should be familiar with some of these acronyms. Even if they're passing notes to one another, there's often a case where they may come into contact with the acronyms that you may see here. So you may want to ask your students, why are the acronyms used in text messaging important? What's the value, or what do they allow us to do? And also, are there any disadvantages of their use? So many students can probably quickly realize that the value of text messaging acronyms is that it reduces the number of buttons that the student has to type on their phone. So they can compose a message more quickly. They may also be able to compose a longer message with using shorter number of different characters by using the acronyms. So a very common thing that your students may interact with day to day could lead into an activity that also illustrates the idea of text compression. So Baker Franke at Code.org has built a really interesting widget that can help to illustrate text compression in a fun way and bringing some activity to your classroom. So using Baker's idea, you may want to visit this website and look at this widget that's been created, and then group your students into pairs and ask them to work together to solve certain compression problems. So there are various poems and other statements here that can be selected from this widget, and the goal is to add to the dictionary ways of compressing down the original message using symbols. So you may ask them to try to find the dictionary of acronyms that yields the largest reduction in overall size, and they could even have a little bit of a competition to see who might be able, or what group or pair of students can find the dictionary that would reduce the particular poem at the largest percentage. So you might also ask your students, after they've done this for a while, is to Ask them what kind of observations they can make from this experience. So what strategies did they use when they were trying to arrive at their best solution? And finish up the activity by asking them if this is an example of lossy or lossless compression. So let's just take a quick look at this example and try it out, and then see if you can derive a way or a lesson plan to introduce this to your own students. In this text compression activity from code.org, we have two common phrases that we are asked to replace in a dictionary and to further compress this. So we have a compressed sentence or phrase here and a dictionary. So the overall represented phrase is the compressed part and the dictionary stored, and we can see some statistics at the bottom left of the screen. So I'm just going to take a guess here and pick a few. Peter Piper picked will be one particular dictionary entry. So we'll put that as a symbol over in the dictionary, and the compressed version then replaces that phrase with every place it appears. And you can see the symbol there. And another phrase we may pick here is a peck of pickled peppers. And if I create a new symbol there representing that, we can see that the compressed version gets smaller. I'm down to 48.26% compression rate, and my dictionary on the right there. So that's the two first symbols. But if you look, I can take out the underscore of peck, underscore a underscore, and it makes it even better. So 57.71 if I add just the underscore in front of it. So I now have two good symbol candidates there for my dictionary. And I can even take symbols out and compose symbols of other symbols. So I do the underscore first symbol there. I can now come back. It's still around 57.71. There's an opportunity to do one more. So there's an underscore A, and that'll keep me also at 57.71, but the actual compressed version is much smaller. There's a second activity here from code.org where they have some other text that we can look at, and you can also write your own. So in this particular case, I'm just going to try and do a long phrase, pitter patter underscore pitter patter, and see how that works. That gives me 25.81. But interestingly, if I were to reduce that a little bit and cut that in half, so the symbol instead is pitter underscore patter, I get a much better compression rate, 36.56. So these are things that your students can explore and try to understand why. I can then do a symbol of a symbol. So I can do the umbrella here, and I'm now at 37.63. Another one, let's see, let's do the second one, a tutor. So let me erase the previous dictionary. That actually puts me in negative if I don't erase the previous dictionary here. So now if I do underscore tutor, underscore tutored, and let's see some other things I can pick out of here. Underscore 2 at 10, underscore the, that's 12. It's not particularly a very good representation. Now if I come up with underscore 2, I can get much better. I'm at 25%. So probably that can be done a lot better. There's underscore odors there, O-T-E-R-S. So this could probably be done better, but maybe try that on your own and see if you can beat that. Here's an interesting one where students can play around and understand how to optimize this. So if I pick all or just a subset except one here, or if I pick all of them, maybe all but the first one, these actually, the case doesn't matter. But I'm actually gone negative because it takes space to represent a dictionary. So I'm representing that symbol and then also copying it into the compressed phrase. So if I pick just maybe half of that, I can start adding A's to the end where I can see the compression rate getting larger to the point where I had the compressed image as just two of the same symbols. So 47.66 is pretty good for this one. I'm not sure how much better we can do that. Your students may also be encouraged to create their own phrases that they might want to share with other classmates. And the actual idea of text compression can be motivated as a sort of competition. So you can give some of these phrases out to your class, ask them to work in groups, and maybe collaborate and see within a few minutes which groups can come up with the best compression ratio. So overall, this is a very good activity to introduce the idea of algorithms, in particular of compression, and the idea in this case of lossless compression, so the ability to recover the full message without any loss of information.